Alright, so today we'll be talking about radian measures, which closely follows on the heels of unit circle. Okay, so last time we talked about using the unit circle to work with stuff. Okay, so this is initial position, this is the terminal position of our angle, and in here is actually going to be theta, whatever you want to call it, whatever name the angle you want to call it. This would actually be the central angle, okay, of this actual object. Okay, now this right here on this side, this green part, is the intercepted arc. Now it actually has a length, and we would call that length a radian. Okay, and so this is measured in radians, its length. All right, so please understand the lengths we're actually going to be talking about are radians. Okay, now if we take a look at this circle, let's get rid of all this extra stuff. Okay, if we take a look at this unit circle, all right, this is the unit circle. The circumference would actually be 2 times pi times the radius, which would be 1. Okay, so circumference equals 2 pi. Okay, so that means that the total distance, if I start from here and go around this circle, and it doesn't matter which way you go, well, it does, because remember, if we're going negative, we're going to go the other direction. Okay, but it's actually going to be a length of 2 pi. So now, if you notice that angle measurement, that means that the angle that corresponds with that is going to be a radian. Okay, so that's going to be 2 pi radians around. Okay. All right, just to go around. Now, if we only go halfway, okay, if we start here and we only go halfway, that would be, so that's 2 pi radians around. Okay, if we only go halfway, that is actually going to be 1 pi, which is half of 2 pi, which makes sense. So we would call this pi radians around. Okay, all right. And once again, if we only go half of that, we would be going pi halves. So that would be pi halves radians around. Now, here's the cool thing, is that you can actually half that again. Okay, and that would be halfway in between the 90 degrees and that. Okay, and so that would actually be pi quarters. Okay. All right, now the numbers that actually correspond with these. Okay, so 2 pi radians around would be 360 degrees. Okay, pi radians around would be 180 pi, or 180 degrees, I'm sorry. Pi halves would correspond with 90 degrees, and pi quarters would actually correspond with 45 degrees. Okay, and that's the cool stuff between that. Now, if you use all these conversions right here to actually work with it, okay, to go from degrees to radians, you multiply by pi divided by 180 degrees. Okay? All right. Now, if you wanted to go backwards, to go from radians to degrees, you multiply by 180 degrees divided by pi. Okay, let me get rid of that part right there, that misspelling. Okay, so here's the cool thing. Now you can either use a chart and identify the pairings and just, oh, if I'm dealing with 360 degrees, that's the same as 2 pi radians. Okay, now the angle is going to be the central angle, so the degree is going to be the angle, but the radians is going to be the distance around, just as we work with it, okay? All right, let me get rid of all this extra stuff and we'll start on some other different stuff. All right, so right now, we went around basically in quarters and everything. So right now I'm going to go back around I'm going to go about halfway, and we talked about that being pi. All right, so that's a total distance of pi that we went around. Okay, now if I only went a third of the way, all right, now if you notice that lines up with 180 degrees. Okay, if I only went a third of the way around, that would be about 60 degrees, and that would be about pi thirds. So 60 degrees, and that's pi thirds. Okay, and if I went half of that, okay, that would reduce it to 30 degrees, and that would actually be called pi 6, because half of pi thirds is pi 6, which makes sense. Okay, now you can go around multiple versions of this, and I'll write that out in a second, but a lot of these actually correspond with fantastic degree angles. Okay, and if I multiply this by 2, I get 2 pi thirds, which is same as multiplying 60 by 2. And if I multiply this by 5, I get 5 pi 6, which is 150 degrees as well. I'm going to go to a different screen and actually show you the unit circle with all their measurements lined up. Okay, now everything is just lined up right here. This is actually a unit circle with all the cosine and sine values with it. But what I'm also going to do is I'm going to show you one with all the angles lined up with their radian measures. Okay, and here it actually is. And so what you can do is you can go back and forth between the past couple of seconds and actually write out all the corresponding sides and everything. Okay, but now you also have another unit circle with the actual cosine and sine measurements on the outside, so you know the exact measurements of the points on the circle as you go around. And plus, if you notice, there's proper negatives and positives in each spot. All right, so once again, to go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, you multiply by 180 over pi. All right, now if you need to find the length of an intercepted arc, so in other words, that you know the actual measurement of, let's say you wanted to know the actual length of this. Okay, now obviously the length of a unit circle is definitely going to be just whatever the radian measure is going to be. But if you make this bigger, like let's say instead of 10, but it was now 7, okay, you would need a formula for that, and that's where we get the length of the intercepted arc is going to be r times theta. Now theta does need to be in radians, so in radians. Okay, if it's not in radians, you're going to have a heck of a time working with this. So all you need is those two things, and you can actually find the actual arc length right here, and it just depends upon those two and just works with those two. Okay, all right, that's it for radian measure. I'll talk to you later. Bye.